Okay, welcome. Today we're talking about linear equations, graphing linear equations, word problems that kind of take the form of a slope-intercept, and basically taking word problems and associate it with a slope and intercept and maybe a graph. Here's a good one. It talks about a bank loan at 2.5% with some fees of about $250. What I like to do is kind of make a list of what I have, such as a loan, my interest, my fees, and kind of try to come up with what parts of the equation that is. So we don't know what our loan is, so let's give that a variable. We know our interest is 2.5%, and we know our fees are about $250. So let's say we kind of created and looked at what a graph of that might look like, meaning that at zero, so if my loan was zero, what would be the cost of my loan? Well, it would be about $250, right? And each amount of loan, let's say I was going up by hundreds, that would be applied to my interest. So essentially it would be going up. So, and here my loan at 100. So this kind of gives me an idea of, okay, well the 250 looks kind of like my intercept. So let's just say we ran a simulation and said, okay, if I'm gonna take an interest of $100, now this also helps me understand that I have to take my 2.5% and I have to change that to a decimal by moving 2 to the left, calling this 0.025. So if I'm going to start putting this into my equation, I need to convert it from basically a percentage to a number. And if my loan was $100, I would pay 0.025 or 2.5% of that 100 plus my 250. So by coming up with basically simulating or coming up with or running an example, I could basically come up with my equation and understanding that what did I put an input, remember x, I put an input of 100 or my x, and I had a flat fee at 0 of, or my y-intercept of 250, and what changes or what is applied to my input here, my slope. So I could basically come up with my y equals mx plus b by creating a graph and running an example or a simulation, putting in an arbitrary value of 100, and by figuring out what that would give me, I could come up with my graph here and come up with an output. So this is a good way to come up with our answer here, let's say, of 2.5x plus 250. This is the equation we're looking for. Here's another good one. Talks about an athletic club, the 223 in advance. Each time that person uses a club, 5 is deducted. That's a big word there, deducted. That basically is talking about doing some level of subtraction there. And again, I like to simulate, meaning, okay, if I paid 223 in advance, so basically this is what I have in my account, and each time, let's say I use the club 4 times, well, that means I'm gonna take 223, I'm gonna take 20 off my account, so I have 203 in my account. And by doing that, I've created that equation, 223 is equal to 5x. So my output, or what's left in my account, is what I already have in there minus or deducted 5 times each visit. And then it asked me to figure out what would be left in my account after 9 visits. So we know 5 times 9 is 45, so we're going to deduct that from the 223. And I'd like to show you too how I go about subtracting this mentally. So basically I'll subtract the 40 to get to 183. And then I'll subtract 3 to get to 180. And I'll subtract 2 to get to 178. And I got that by basically splitting up that 5 into a 3 to get me to a 10, a 10's place with the 0, and then subtracted another 2. This is a good little mental math trick here. And basically I end up with an output, remember y being our output, of 178. And that would be the value remaining in the account. And that's essentially what I'm looking for. Here's another good question. Now, in the other ones, we made a list, basically, right? So, or we made a simulation. This one, they're talking about a river and a bridge. So I think it helps to just make a little diagram, even if it's a simple diagram of a bridge and a river, and then kind of looking, okay, in 80, the river was 24 feet below. So give yourself a visual of this being 24 feet below in year 80. And then it continues on to say that the river is 12 feet below in 88. So about halfway in 88, it's about halfway up to the bridge. So notice the feet are going down. So we might have a negative slope here because the amount of feet close to the bridge is decreasing. It's decreasing. And what I like to do is kind of see, what is the change? What is the change in feet, or the change in y, feet, over the change in x, let's say year or time, so we'll say years. And what I could do is come up on a coordinate for that as being year 0 in 80, it's at 24 feet, and at year 8 years from 80, it's at 12 feet. And then I can run a slope. I can run a slope here, subtract my y's, 24 minus 12, over my x's, 0. Oh, I'm sorry, this should be 8 and 0. And I would get 12 over 8, or 3 over 2. So that means for every 2 years, it's decreasing by 3 feet. And I know it's decreasing here, so that's why I'm adding this negative here. And be careful, because you also might see times where they give you maybe decimal, 7.5 over 5, like this. And how do I reduce that? It's a decimal. I don't see the slope. Well, know that 2.5 goes into each of these numbers. So that's another way to reduce to 3 over 2 there. Now that I know basically my slope, my change in x over my change in y, I can put that into y equals mx plus b. I could put that in my slope-intercept form and say, okay, my output, or my feet closest to the bridge, is equal to 24, which is what I originally started with, minus decreasing 3 feet for every 2 years, based on the amount of years I have here. And in the question, they want to know, if nothing is done, what year will the river reach the bridge? So when the river, what year here, x, will the y be what? If the river has now reached the bridge, your y is 0. It's at 0 feet. And you're trying to figure out at how many years will my feet be 0. So what I've done was, if I substituted 0 feet in for my y, so I can solve for my x. And then I'll multiply top and bottom here to get rid of, actually, what I want to do is get rid of this 24, or move this 24 to the other side. Negative 24 is equal to negative 3/2 x. And then get rid of my fraction. Much easier to do that. And then I get negative 2 over 3 to both sides. That cancels all this out here. So I'm left with and what I do to one side, I do the other. Negative 2 over 3. And now x is equal to whatever, negative 2 times negative 24. We could put this over 1. Negative 48. Or negative and negative is actually a positive. 48 over 3, which is 3 goes into 4 once, with 1 left over, 19 years. So after 19 years, my feet below the bridge is going to reach 0, meaning my water is going to be touching the bridge. So where was that? Well, that was 1980 plus 19 years, or 1999. And that would be your final answer there. And again, the diagram helps you create coordinates, which helps you find a slope, which helps you come up with an equation in which you're subtracting from the amount of feet you started with by the amount of years you have, and then allowing you to plug in 0 for y, because you want to know how many years will my feet be 0, and then coming up for how many years that would actually take. Hope this helps. Make sure you go through the steps. You can stop and rewind, and should be able to get through a multi-step problem like this. Thank you.